All right, let's solve this. Let's solve some problems on motion. Okay, the first problem we're going to solve said a man runs at a velocity of this. They gave us the velocity, and the velocity they gave us is what, 6t cubed plus 4t squared minus t plus 5. Okay, then I say we should calculate the acceleration, and we know that acceleration is simply what, the v over the t. So which is what, which is equal to, differentiate this, I know how to differentiate, multiply by the power and remove 1 from the power. So 3 times this is what, 18t squared minus, multiply by the power, remove 1 from the power, I'm having 8t. Differentiation of this is 1, and differentiation of a constant is 0. Please, if you don't know differentiation, go back to my video on differentiation, you will get that. Okay, so now to calculate the velocity, they gave us at the time there. So they gave us at t equal to 1. I'm having that the acceleration he covered is equal to what, 18 bracket 1 squared minus 8 bracket 1 minus 1. So I'm having 18 minus 8 minus 1. Okay, which is this is 10 minus this is 9. So I'm having 9 meter per second squared. You see, it's very simple. Then I said calculate the what, the distance. They gave us that the velocity is equal to what, 6t squared, 6t cubed, sorry, plus 4t squared, okay, minus t plus 5. Please, we are going back now. We know that what, that velocity is the same as what, when you differentiate speed, the s, the t. When you differentiate speed, you are getting velocity. Okay, so look at this one. When you differentiate velocity, they gave us, we are getting speed. But this one, they give us velocity, but when you differentiate speed, now you get velocity. So to go back, I want to get speed. Speed is what they asked for. The speed is equal to differentiation, going to the other side becomes integration, which means I need to integrate v with respect to t. Okay, so we are integrating now. So note what I'm doing now. But here, acceleration is simply differentiate v. So which is what? Which is equal to what? Differentiate this thing with respect to t. That's the meaning. But this one is that I want the s here to be constant. So this time this, I'm having vt, and d means differentiation. Differentiation crossing to the other side becomes integration. So I'm supposed to have what? The integral of 6t cubed plus 4t squared, okay, minus t plus 5 dt. Okay, so what do we have now? We are going to have permit me to clean here. Okay, okay, so they gave us this. So I'm going to have that s is equal to what, 6t raised to power 4 over 4 plus 4t raised to power 3 over 3, okay, minus t squared over 2 plus 5t plus a constant. So this is the integration. Please, if you don't know integration said add 1 to the power and divide by the same power. So I'm having 3 plus 1 4, I divide by the same 4. 2 plus 1 3, I divide by the same 3. This one is 1 plus 1 2, I divide by the same 2. This one does not have anything, just put the t. Then you must put plus a constant at the end of integration. Okay, so I'm having so what do I have? At t equal, I just framed the question anyways. At t is equal to 2, so I'm going to have that the speed there is equal to what, 6 2 squared over 4 plus 2 raised to power 4 over 4 and 2 raised to power 3 over 3 minus 4 minus what, 2 raised to power 2 over 2 plus 5 bracket 2 plus a constant. So just do it and get the result. Problem. Okay. So I'm just trying to show you the concept, because I looked for a question and I couldn't find. I'm just trying to show you the concept, that so that you know when you are differentiating and when you are integrating. Okay. So the next question here said number 2 question. Solution to number 2 question said King Smarties walks from hall B to hall A and covers a distance of this. They gave us distance. They've given us distance to be what? 4t squared minus 3t plus 10. Okay, so the first question said that we should find the velocity, and I know that velocity means what? ds over dt. Okay, so which is what? Differentiate 4t squared minus 3t plus 10 with respect to time. So what do? Differentiate this means multiply by the power and remove 1 from the power. I'm having 8t minus differentiation of 3t is just 3 and differentiation of a constant is 0. So at t equal to what they give us, at t equal to 2 seconds, I'm having that the velocity is equal to what? 8 bracket 2 minus 3, which is what? 16 minus 3, which is what? 13 meter per second. Okay, so the next thing they say we should find is the acceleration, the acceleration. And I know the acceleration is what? dv over dt. Okay, which is what? D. I've gotten v as 8t minus 3. So I'll say d 8t minus 3 all over what? dt. And which is equal to acceleration. Differentiate 8t, I'm having 8. Differentiate minus 3 is 0. So my answer is simply 8 meter per second square. You see, as simple as that. So let's continue solving more questions. So number 3 question. Okay. The third question said a man, number 3, a man runs a distance of 1.0 kilometer in 5 minutes. Okay, then find his average speed. Okay, solution. Now the first thing they gave us is that the man runs the distance the man runs. Okay, because they're talking about speed, so this one will be distance, but if this is velocity, this one will be displacement. So the speed there, okay, the speed, bring out your parameter. The speed is equal to what? The speed, sorry, not the speed, but the distance first. The distance they give us is what? 1.0 kilometer, and kilo means 1000, so it will be what? 1.0 times 1000 in meters all over what? Okay, sorry, that is that. So which will give you what? 1000 meters. I've gotten 1000 meters as the speed. Then the time is equal to what? 5 minutes. And 5 minutes, to convert it to seconds, is what? 5 times 60, which is what? 300 seconds. So the speed now, the speed is equal to what? Distance over time, which is what? 1000 divided by 300. So I'm having 10 over 3 what? Meter per second. Okay, as simple as that. So number 4, you see, it's very simple. Number 4 said a car traveling at a uniform speed of 100 kilometers per hour, okay, spends 15 minutes moving from A to B, okay, along its route. Then find the distance between A and B. Solution. Now they gave us the speed. The speed is equal to what? 100 kilometers per hour, which is what? 100 times kilometer is what? 1000 meters all over. Hour means what? 60 times 60, to convert it to minutes. Okay, so I'm having what? That's to convert it to seconds. Sorry, to convert hour to second. So I'm having what? 0 cancel 0, 0 cancel 0. So I'm having 1000 divided by 36 in meter per second. Okay, so this is my speed. Then the time they gave us there is 15 minutes, and 15 minutes is something as saying 15 times 60 to convert it to seconds, which is equal to what? 15 times 60. So I'm having 900 seconds. So to get what I'm asked to find, they say I should find the distance. I know that distance is taken as what? Speed times time. And which is what? What is my speed? My speed is 1000 over 36 times 900 over 1. So what do I have? If I divide by 36, then I'll now times, well, that is 25,000. 25,000 meters. 25,000 meters. Okay? So that is that. And 25,000 meters, let's say 1,000 means kilo, which is what? 25 kilometer. Okay, because 1,000 means kilo. So number 5. See, this thing is very, very simple, and you will enjoy it. Number 5 says a train with initial velocity of 20 meter per second is subjected to a uniform deceleration. Deceleration is something as retardation. Deceleration of 2 meter per second, okay, per second square. And they said find the time required to bring the train to a complete halt. Okay. Now, listen. They gave us the initial velocity to be what? The initial velocity is equal to what? 0. Sorry, it's equal to 20. Sorry, the initial velocity is equal to what? 20 meter per second. Please, if something is retarding, it means that thing will stop. It will get to a place, it will stop. So the final velocity of that thing should be 0. So the final velocity is now what? 0 meter per second. That is the final velocity. Okay? And they gave us what again? They gave us the retardation, which is acceleration, which is what? 2 meter per second square. In fact, if you cannot remember the formula for acceleration, just write out the 4 equation of motion, the 3 equation of motion, and know the one to use. The first one said that what? V is equal to U plus AT. Okay? And the next one said that what? V squared is equal to U squared plus 2AS. And last one said that S is equal to UT plus 1 over 2AT squared. I check the one that they say we should find the time. The time is what I'm required to find. Now check the one that has these 4 things you have. Velocity is here, velocity is here. U is here, U is here. A is here, A is here. So I'm going to use the first one. So I'm saying that what? V is equal to U plus AT. So I'm going to have that what? My V is 0 is equal to what? My U is 20 plus. Please, the A you are going to use here, because it's retardation, it will not be a minus. So it will be what? Minus 2, please. Minus 2, then times your T. Why did I use minus? Because they are talking about retardation. Retardation is negative acceleration. So what do you have now? This 0 is equal to what? 20 minus 2t. This one move here. So 2t is equal to 20, and t is equal to what? 20 divided by 2, which is what? 10 seconds. 10 seconds. You see, it's very, very simple. So the next question, we'll solve many questions so that you will get to understand it very well. So the next question, number whatever, I think number 4. Number 4 said a body accelerates uniformly from 3 meter per second. Okay, from rest. Accelerate uniformly from rest, okay, at 3 meter per second. Full stop. Find its velocity. Okay, after traveling a distance of 24 meters. Full stop. So let us bring out everything we have. Solution. Okay, they gave us what? A body accelerates uniformly from rest. This body started from rest. So if this thing started from rest, it means that the initial velocity is 0. A body accelerates uniformly from rest. Okay, so okay, this started from rest, so u is equal to what? 0 meter per second, and traveled at what? The final velocity here is what? 3 meter per second. Okay, then we are asked to find okay, sorry, 3 meter per second square. So this is the acceleration, sorry. So the acceleration there is 3 meter per second square. It's a mistake. It's accelerate at 3 meter per second square, but it started from rest. So we need the final velocity. That's what they asked us to find. After covering a distance of what? 24 meters. So let us check the one that will have all these things from the 4 of them. Always, or 3 of them, always write it out, please. The more you are writing it out, the more you are becoming familiar with it, and you will never forget it. So keep writing it out. Then the first one is what? V is equal to u plus at. The next one is v squared is equal to u squared plus 2as. The next one is what? S is equal to ut plus 1 over 2 at squared. Okay, so I think I'm using the second one because there is no time. So I'm having v squared is equal to u squared plus 2as. So I'm having v squared is equal to 0 squared plus 2 bracket 3 bracket 24. So I'm having that v squared is equal to 24 times 6. I'm having 144. So v is now the square root of 144, which is what? 12 meter per second. You see, it's very simple. Once you know these 3 things, you can solve any question given to you, okay, in motion. So the next one we're going to solve, number 5. Number 5 says find the time taken for the body in the above question, okay, to cover above question number 4 to cover a distance of 24 meters. Okay, so from this same question they are now asking us to find the time. Okay, and to find the time, I know, let me write the 3 of them and know the one that has time. I have that v is equal to u plus at. Okay, this one has time. Let me use it. V is equal to u plus at. So I'm having that what? V, or let me use the one that has seconds, because since they're telling us this distance. Now you can use this one, you can use this one if they did not change the distance. Like this is 24 and this is 24. This one will work. But if this distance has changed, please look for the one that has distance and that time you are looking for. So I know that S is equal to ut plus 1 over 2 at squared. In fact, that is what I'm going to use. S solution. S is equal to ut plus 1 over 2 at squared. So I'm having that s is 24 is equal to u, initial is 0. So I'm having 0 bracket t that I'm looking for plus 1 over 2 bracket my a is 3 and I'm having t squared. So I'm having here 24 is equal to what? 3t squared over 2 because this is 0. If I cross multiply, I'm going to have what? That t squared is equal to 2 times 24 divided by 3. So t squared is equal to, so I'm having 2 times 24 then divided by 3. So I'm having 16. So this is 16. So therefore my t is equal to the square root of 16, which is what? 4 seconds. 4 seconds. You see, as simple as that. This is one of the easiest topic in physics. Okay, so the next one, number 6. Number 6 says a body accelerates uniformly from rest at 6 meter per second square for 8 minutes. Okay, for 8 seconds. Okay, then I said and then decelerate uniformly to rest in the next 5 seconds. Okay, find the magnitude of the deceleration. They say find the magnitude of the deceleration. Okay, solution. Okay, so they say that a body, let's bring out everything we have. They say that a body accelerates uniformly from rest. So u now is equal to what? 0 meter per second. So at acceleration of what? 6 meter per second square. And the time they gave us is what? 8 seconds. Okay. This one now that I have here will help us to get the velocity. This one now will help us to get the velocity. And what is the velocity now? The velocity here will now be, I know that v is equal to what? U plus at. So v is equal to 0 plus what? 6 bracket what? 8. So my v is equal to what? 48 meter per seconds. Okay, so the next thing we are going to do is they now say that it now started retarding in the next 5 minutes. It started retarding in the next 5 minutes. Okay, so how do you do that? 5 seconds, sorry. The retardation starts from the next 5 seconds. So what do we do now? We now have I know the same formula that said that v is equal to u plus what? At. Okay, but in this case now, the initial velocity now becomes 48 meter per second, and the final velocity now is 0 because it is now retarding. The velocity started from here and start retarding. Okay, so and the time taken for this thing to happen is 5 seconds. So I'm having that what? V is equal to u plus at. So I'm having that what? 0 is equal to what? 48 plus a bracket 5. So I'm having this come here. I'm having minus 5a is equal to 48. Okay, so I'm having that a is now what? 48 divided by 5. So what do I have? 48 divided by minus 5. So I'm having, I think, minus 9 point something, minus 9.6 meter per second square. Now you see, why is this thing in minus? Who can tell me? It's a minus because we are talking about what? Retardation. And retardation is what? Negative acceleration. Negative acceleration. So I'll solve one more question on this. Then we'll talk about the solving it graphically, using graph to solve it. Number 7, or let me just solve 10 questions. Number 7 said a body undergoing a uniform acceleration move, okay, undergoing a uniform acceleration motion has 2 points 1 second, 10 meter per second, okay, and 20 second, 48 meter per second, okay. These are the 2 points on the velocity time graph. On the velocity time graph of its motion, okay. Then find the acceleration of the body, okay. The acceleration of this body is very simple. You know that acceleration means what? Change in velocity over change in time. Don't forget this formula, which is what? V2 minus V1 all over T2 minus T1. So call this time, the first time T1, the first velocity V1, the second time T2, second velocity V2. So what am I having? So this is equal to what? A 48 minus 10 all over 20 minus 1. So I'm having 38 over 19, which is what? 2 meter per second square. You see? Very, very simple. Very, very simple. Okay. So the next question, number 8. Let's be fast. So we get to 10 questions and then we move to velocity time graph. Number 8 said a motorist traveling at 72 km per hour, okay, 72 km per hour on sighting a stop road sign, applies the brakes such that under constant deceleration, the car is brought to rest. Within a distance of 50 meters. Calculate the magnitude of the deceleration. Okay, so we're asked to calculate the magnitude of the deceleration. It's very, very simple. They gave us that the speed that this man is using, the velocity, final velocity. In fact, the initial velocity he used, this is the initial one he used, which is what? 72 km per hour, which is what? 72 times what? 1000 because of kilo divided by 60 times 60. So what do we have? This and this, take care of this and this. So I'm having 720 divided by 36. So 720 divided by 36. So I'm having 20 meter per second. 20 meter per second. Okay. So they now said that they gave, what else they give us? The distance. They gave us distance to be what? 50 meters. they gave us distance to be 50 meters. So let's look at, we have that v is equal to u plus at, and I have that v squared is equal to u squared plus what? 2as. Can we use this one? Yes, because they're asking us a. I hope you know they're asking us a, but that a will be negative. So the final velocity is 0 meter per second, because the thing came to rest. So I'm having 0 squared is equal to what? 20 squared plus what? 2 times a times 50. So I'm having minus 100. This time this is 100. Minus 100a is equal to 400. Yes. So I'm having that what? A is equal to what? 400 divided by what? Minus 100. So a is equal to what? Minus 4 meter per second square. So but the answer is not minus 4 but 4. Are you getting it? Because they are asking you retardation. Retardation is negative acceleration. Having negative shows that it is retardation. So the answer is simply 4 meter per second square. Okay, but the minus shows that you are not, the answer you got is not acceleration but retardation. Okay, so thank you very much for watching. In the next video we'll now talk about solving it with velocity time graph.